Reasoning of properties. All
right, guys.
here we are.
We're in section 5, and we're trying to make a transition here.
Yeah.
Trying to make a transition out in oh, I hit that too many times earlier. Things you talked about really in math classes leading up to this, certainly in algebra, but before that too. But we tend to forget them for whatever reasons. But they're just basic properties of numbers and so on, basic properties of addition. I mean, of algebra certainly. But then we're trying to make that true to what we do in geometry.
Yep.
That really makes, in most minds, what makes geometry hard.
Yeah.
And so this really is a critical section for just making that, starting to make transition to what we're in the next chapter. So
just kind of always keep in mind what it says at the very top there of if we say this, then we can say this. And that's the key to this whole thing. Because of this, I can say this. And you kind of have to remember these things in order to really make it work. It's cause and effect, cause and effect, cause and effect. Or you know, reason, or you know, idea, reason, idea, reason. So it's what can you conclude, basically, guys. And if you keep that in mind, it really is to make sense. Like if you look at the top here, I can just start off. At the very top, it says for properties of equality, it says at the very top in the red there, equals B, then. Okay, so let's just say a number. So if A is 3, what's B got to be, Mr. Scritchfield?
B's got to be 3.
If B's got to be 3. If they're equal, they got to be the same thing. So if I come to the addition property, basically it says if I take A and I add to it, then I must also understand that I could take B and add 2 to it and they'll still be equal. And so
it's the whole concept of an algebraic equation.
Exactly.
All the rules we talked about in algebra, and again, if you think about an algebra equation being a balance, the whole thing was if you do something to one side, you got to do it to the other, or you throw the equation out of balance.
That's right.
That's all these are.
So if I put 3 in there again, 3 plus 2 is 5. Well, if I put 3 in for the B, is 3 plus 2 still 5, guys? And the answer is yes. Okay, and so it's the same thing on the subtraction property. If we know A and B are equal, if I take 2 away from A, and I must also take 2 away from B in order to keep that balance balanced. Go down to the multiplication property. If I multiply A by 3, well, in order to keep it balanced, so multiply B by 3. And that's kind of the multiplication property. If I multiply 3 to one side, I got to multiply 3 to the other.
Right.
Division property, if I divide A by 3, I got to divide B by 3. You know, you see division on one side, you got to do division on the other. And then, you know, my personal favorite, the distributive property, because it kind of looks a little bit different, but it really says the same. If I have the quantity of B plus, I can't add B plus C together. All I get is A times C. It keeps it balanced.
Right.
And, you know, we always property going from that, but if you learned how to spread out certain multiplication problems faster.
Oh, yeah. Yeah.
But,
right. So these are all just all based on the fact that if A equals B, that assumption has to be true.
That's right.
We're assuming the hypothesis is true, then all these separate conclusions can end up being true. So we're back to our if-then statements, hypothesis, conclusion. Okay? So your problem sets tomorrow are going to have things to do with applying these properties.
Right.
So.
And it's really, guys, just solving some algebraic problems that you've done all through Algebra 1, and then listing what rules you use to get there. And you kind of, if you look at this example right here, if I have 4x equals 12, well, a lot of you guys are, just divide by 3 to both sides. Well, or excuse me, divide by 4 to both sides. Well, what property is that? You have to say that in geometry. And so I would say, oh, that's the division property. I mean, it's that easy. Okay? Right. So, Mr. Scritchfield, if you see 1/5 x equals 2, well, what are you going to do to solve that?
Well, that one's a little bit, because fractions tend to throw us, and it shouldn't be that way. Okay? But don't see that as division. In a way, it is division and so on, but what we're going to do to solve that, that's the same thing as having x over 5. And so the x is being divided by 5. So again, what would you do to solve it? What would you do to the opposite of that? The opposite would be to multiply by 5. And so this is going to be the multiplication property. If I multiply both sides of that by 5, the 5's cancel on this side. 5 times 2 on the other side is what gives us the 10. And so that one ends up being the multiplication property, okay, not division. So make sure that you see that, okay?
And then on the next one, maybe.
It's being slow. Computer's being slow here.
If I have x minus 5 equals 2, okay, well, in order to get x by itself, I'm going to need to add 5 to both sides. So that is the addition property, and we just need to understand that, you know, that's what we did, so we want to list it. And you'll see on the way your homework is kind of set out, It'll say, all right, list out this. It'll show you, you list out what you're doing in your math, and then over here you're going to say which step for each one.
Right, kind of like the
Yeah.
table a little bit. And so again, we go back to our algebraic equations. What's happening to that x right there? It's having a 2 added. So what are we going to do? We're going to do the opposite. We're going to subtract 2 from both sides, and so it's the subtraction property. All right? So that's what kind of our problems with these properties are going to look like.
Yeah, it's basically just doing the algebra you've done and listing out the rules. Okay, so here's kind of a more, some really, well, some of them are really important as we go through the year, and others of them we don't use quite as much, but it's this whole idea of if then again. So if A equals B, then we can generate some more rules. The substitution property, I always kind of talk about this one as like a sports team with the substitution. So let's say Mr. Scritchfield and I are both the quarterbacks for the football team, and I'm having a really bad game. Well, even though Mr. Scritchfield is a completely different person, because we play the same position, my coach can sub me out and put Mr. Scritchfield in, and it's the same person basically playing the same position.
Yeah.
So we deal with substitution in sports all of the time. So I mean that's basically
so as long
the
as
substitution
values
property.
are equal,
Yeah.
you can just swap them out for each other.
That's right. The reflexive property, guys, we're going to use that one quite a bit.
I know, and that seems like maybe to you that nothing's going on here, but it is a property that we use a lot later. And so make sure you get, in fact, you're going to like this one because it's an easy one later, as opposed to some of the hard ones we have. So, so the reflexive property, think of a reflection in a mirror. If you put a mirror right down through the middle of that equal sign, it looks exactly the same on both sides. Anything is equal to itself is basically the way we say this one.
Yep.
Or when we use it for congruent, anything is congruent to itself.
Right, and we're going to use it a lot, guys, so just learn this rule. If A is 3, then it should equal 3. I mean, that's kind of the idea. Symmetric property, I don't see this one being used as much in geometry.
No, not as much.
Sometimes here and there.
Yeah, we don't use
It's
it
not
very often.
as important, but it is there. But it basically says that if A equals B, then it should be okay to say that B is also equal to A. It's kind of like a segment. If a segment is 5, it doesn't matter which way you look at it. It's 5 no matter what. I mean, it really isn't that big of a deal. If A equals 3 and B equals 3, well, then it just doesn't matter which one's on which side. They're still the same.
Right.
I mean, I don't know if you want anything to add to that.
No. And then transitive property is a huge one.
Yep.
We use it over and over and over again. You've got to catch this. And the whole concept of 3 comes in here. So if we have the first item A equal to B, like it says up above, but we also know that that same second item, B, is equal to a third item, C, well, that forces the first and third to be equal to each other also. So A is equal to B, and B is equal to C. That's given to us. We know that. What we conclude is that A also has to equal C. That's the transitive property.
To me, it just kind of reminds me of the algebraic version of the law of syllogism.
It is, yeah.
Because look, B is the middleman. Get rid of B, and A is equal to C.
Yep.
Since A is equal to B, B is equal to C, dump B, and A is equal to C.
Right.
So, I mean.
But we use reflexive and transitive. We use over and over and over again through the rest of the year.
Yep.
You need to know those.
Yep.
And here they seem pretty basic. They get a little bit more complicated later, but not much. And so you just need to see how they apply.
Yep. So we're going to see some more examples of those here. So you want to take the first one?
So sure, if these two segments are congruent, if segment BC is congruent to DE, then the question is, it's not printed up here, but the question is what property is being used here? Then why would segment DE be congruent to segment BC? And so again, what you need to see is that the segments just got swapped around the congruent symbol, okay? And so this would be the symmetric property because they just swapped order.
Yep.
And so
maybe
there's the symmetric property.
Yay.
All right?
Oh, hey, on this congruent to angle 1. I'm looking in the mirror and I see myself. So that's got to be the reflexive property. Pretty easy one.
A reflection there basically going on. Angle 4 is congruent to angle 5. That's given to us. And it's given to us that angle 5 is congruent to angle 6. And so angle 5 is showing up twice there in the middle. So that's the middleman. And so therefore we can conclude that angle 4 is congruent to angle 6. Why? That's the transitive property. There's 3 things that we're talking about. The middleman comes out of there, and it's the transitive property. You need to see that one. That one's critical to see.
I mean, it kind of goes in kind of numeric. Reflexive is 1 to 1. Symmetric is often 2 to
things
2,
that swap.
and transitives 3 to 3.
Yeah,
You know,
yeah, that's a good one. Yeah.
That's kind of another way I think of it. You know.
Yeah, that's good.
And if you look in alphabetical order, reflexive comes first, symmetric comes second, transitive comes third because
There you
of
go.
RST.
1, 2, 3. That's good. Good memory pattern there.
Yep.
Okay. So this is what we're talking about. This
Yep.
is where we marry these two things of what we know about algebra or just number properties, the fact that we can add something to both sides and so on, and then starting to get into proofs and geometry.
This is actually my favorite thing of geometry is proofs. It's a puzzle.
Yeah.
And it's really they're not easy. Don't ever I don't even think they're easy sometimes. But I just really enjoy them because there's so much information out there, and to really make these arguments and come up with an answer, I think it's really a fun task in math. Period.
They are puzzles, and again,
Yeah.
it's just like anything else in life. It's how your attitude is about them. If you take them on as a challenge like that, they're just a puzzle that you want to take on as a challenge and solve, and it's a step-by-step process. So every step is a challenge. Then take that on. Okay, so let's see what they're giving us. AB is equal to BC. May not exactly look like that, but it's given to us, so we have to accept that. Again, we don't go by the drawing; we go by what's given to us. They're asking us to prove that the length of AB is equal to half of AC. Now, yes, I know you can just look at, okay, well, if AB is equal to BC, yes, it has to be equal to half of it, but they want us to prove it.
Right. So this is not a postulate. This is something we're gonna work through. We just can't accept that it's true.
Right.
You know, I mean, you could look at it and say, "Oh, I see it. That's got to be it." But we got the idea in geometry. You play these games of, okay, we get this idea, but we got to be able to understand why we get this idea. So you have to create a logical argument, and that's the fun of it, really.
Yeah. So where do we always start with a proof?
A given. And so if you guys look at this, you know, so notice how at the top there of the yellow box it says AB is equal to BC, and then right at the top where it says AB equals BC, prove AB, yada yada yada. That's the free information, and this is really the key for you guys. Everybody in this class, no matter if you're good at proofs or not, you have to be able to at least list out given information.
Write down the given information.
You know, I mean,
it's given to you.
It's given to you. You gotta be able to make that connection. I mean, that's the first step really in all this. And so, my only given is that AB equals BC. Now, I want you guys to look at something else. Notice in the yellow box, at the very bottom, it says AB equals 1/2 of AC. So at the very end of this, our last step is going to be the part up there where it says prove. So notice that the given was at the very top and the prove was at the very bottom based on the steps. And so now we just got to go through and figure out all the middle pieces. And this is kind of an easy one because they kind of lay things out for you.
Right. They're just asking for the reasons for each one of them.
Right. So the first thing you want to be able to do here is, guys, say, okay, since I know that AB equals BC, well then what else could I conclude? And so...
And we're given a diagram.
And we're given a diagram.
You can't conclude things from the diagram that are obvious from the diagram.
That's right. And that's another important thing too, is if they don't give you a diagram, guys, you want to draw one.
Yeah.
You know?
Yeah.
So, I mean, whenever I see, you know, AB plus BC, I should look at the diagram and say, oh, let's see, AB plus BC equals AC. To me, I just see, okay, part plus part equals the whole.
Right.
And that was the first one we learned, so that is the segment addition postulate. Okay? Don't be a sap, you have to learn this.
Yep.
You know?
Yep.
Segment addition postulate. So it's kind of a really important one to learn, guys, that part plus part equals whole.
So that's what you need to see there. The AC is the whole segment. The right side is AB, part of it, plus BC, the other part. So part plus part equals whole. That's the segment addition postulate.
Now the next step, well, look at the previous step and look at the step below it and try to decide, hey, what changed?
What's different here?
What's different here? So I see AC above AC from this step and above step 2 to step 3, so that hasn't changed. And then right there, I see AB over AB from step 2 to step 3. Well, that didn't change either. Oh, but BC becomes AB.
How could you do that?
How could I do that? Well, you got to go to the very top. And what do you see, Mr. Scritch?
I see that those two things are equal to each other. They're the quarterbacks of the football team.
There you go. So if Mr. Scritchfield's AB and I'm BC,
we can
substitute out. So this is the substitution property of equality. Maybe.
Okay, we'll go.
There we go. Oh, hey, can't see that. Now, so this one's a little bit harder to see.
Yeah, again, we're looking for the change though.
Yeah.
The left side's the same.
Yep.
AC is the same as AC. The other side though, we had an AB plus AB on the step above. To get to the next step, we have 2 times AB. Well, when you add something to itself, that's the same thing as doubling it or multiplying it by 2. And so really all we're doing is just one of our basic properties of equality here is the distributive property. Now again, it's kind of backwards maybe, if you see it that way. But it is the distributive property here, because you're distributing that 2 through there to get 2 of those same shapes, 2 of those same segments. So this is a distributive property.
Now, the next one is really a moot point with me. I mean,
I wouldn't expect you to put this in.
Yeah, so I mean, really, you could have started out with at step 2 have gone AB plus BC equals AC and skipped this whole step, but they're just trying to show you the symmetric property in action here, guys. But notice that in step 4 above it, AC is on the left and 2 times AB is on the bottom, and then on step 5, you've got 2AB.
Swapped them.
2AB on the left and AC on the right, so they just flipped them over, and so that's just a symmetric property. And you know,
again, you're looking for the change and what happens from step to step, and all that changes, they flip-flopped them.
Yeah.
But yeah, we probably wouldn't have that in very many proofs at all. So
now the tricky part here is to see what happens next.
Right.
And so, you guys go. So how do I go from a 2 to a 1/2? That's kind of a tricky one.
well, how do we go from 2AB to just AB?
Yeah.
It'd be like, how do you go from 2x to just x?
Right.
How do you go from AC to half of AC? Well, you're dividing by 2. You just got to see it that way. So 2 times something going down to 1 of them, and then a full thing going down to half of a thing, you've divided by 2 to get there.
Right.
So what property are we using? The division property. So we had that last in our row of the properties of equality there. So, okay, so you need to be able to come up with reasons for each of those steps. The way we get those reasons is by looking at the change from line to line.
And one thing I really want you guys to remember with this stuff is you're not going to get it on the first try. Most of you. Some of you are going to be like, oh, this is easy.
Yeah,
but
makes sense.
It's just going to take time, and we're going to spend time on these throughout the whole year. You know, we're going to walk through a lot of these, but just you bear with it and not get scared, and just try to understand that if you say this, then you can say this, and so if this, then this. You know, I mean, and so it just takes practice.
Now this one was kind of lined out for us, but how do you know when you're done with a proof?
Well, that's when you have enough information to actually, you know, set up enough things to get that last prove statement in there.
Right. When your last statement is what they ask you to prove.
Yeah, then you're done.
You're done.
Yeah.
So that's what Mr. Bedell was talking about earlier. The given goes first, prove goes last. When you get to the prove, you're done. You've proven what they've asked you to prove.
The real joy is going to come, guys, where all they give you is a given and a prove, and you got to come up with everything else. That's when you know you got this stuff.
Yep.
So,
all right, so we're going to practice some more of these in class. So
Yep.
we'll see you guys there. Oh, I thought I said done.
I'll pee.